Good morning, students. Welcome to the class of Technomathics. So today we'll solve a numerical where a ball is projected vertically upward with a velocity u from a point A, and from the same point A, which is on the top of building, right? A ball is dropped with a velocity, not dropped, it's just thrown with a velocity, same velocity u, as just written into the question. We need to calculate that if it falls freely from the same point, then the time of traveling of that ball will be equal to root over t1 plus t2, where t1 is the time taken in the first case where the ball is projected with vertical velocity, initial velocity u upward, and t2 is the time taken by the ball when it's thrown downward with with the same velocity u, right? So let us solve this question. If this is a building, we have tried just shown two images over here, that the first case where the ball is thrown upward with velocity u from a building of height h, and in the second figure you can see when the ball is thrown downward with the same velocity u with from a height h, that is the same point A, right? So ball is shown in red color and initial velocity is u for both the cases, because you can see in the question same initial velocity, right? So in the first question, when the ball is thrown upward, the value of acceleration due to gravity will be negative, because the ball is going against the gravity, right? And the total displacement will be is equal to h, right? You can see, because h is the shortest distance from the start point to the end point, so we will not consider the ball movement going up and just coming to the same point A and then reaching the ground. So that's why that displacement will be h in both the cases. But in the first case when the ball is thrown upward, the displacement will be minus h, because all of this action is happening against the gravity upward in the upward case, right? In the second case, when the ball is dropped downward, the value of u will be positive, g will be positive, and displacement will be equal to h. Now we know the equation of motion is equal to ut plus half at square. So when the ball is thrown upward with a velocity of u, just put up the values of s, u, and t, right? So in the first case, the time of travel we have considered as t1, right? So here we have just mentioned it. I am just mentioning it, that t equal to t1 in the first case when the ball is thrown upward with a velocity u, and in the second case when the ball is thrown downward with a velocity u, the time is t2, right? So t1 and t2 are the respective times. So putting up these values into the equation of motion s equal to ut plus half at square, we get for the upward direction this equation, right? This equation will become like this: minus h, because that is the displacement which is happening when the ball is thrown upward, minus h equal to u times, that is initial velocity which is already given, into t1 minus half gt square, because the value of a is minus z, right? So from here we get this equation, just deducting the negative sign from the LHS and RHS, we get h equal to minus ut1 plus half gt1 square, right? You can see one minus is cancelled out from the LHS and one minus is cancelled out from all the terms of RHS also. So this is the equation we arrived for the first case when the ball is thrown upward with a velocity u, right? Now in the second case, when the ball is dropped with a velocity u, the value of s will be equal to h, right? So put up the values into the equation of motion s equal to ut plus half at square, right? This is the equation. So putting up the value, we get h equal to, because t equal to t2 over here and s equal to h, putting up the value, h equal to u times t2 plus plus half A will be acceleration due to gravity, that is g into T2 square, right? Now multiply the first equation by T2 and multiply the second equation in the downward case by T1. Why we are doing it? Just to cancel out the terms with u, right? So after multiplying the first equation by T2 and multiplying the second equation by T1 and adding the LHS and RHS terms respectively, we will be having H times T2 plus H times T1 is equal to, into the RHS, you can see, minus U times T1 T2 minus U times T1 into T2, right? Plus half G T1 square is already there, multiplied by T2 will become half G T1 square into T2, right? And into the, and from the RHS of the second equation we get U times T1 T2, right? You can see I'm writing it with different color so that you can understand very easily. Plus U times T1 T2. You can see here T1 T2 with negative sign, minus U T1 T2 and plus U T1 T2 will be cancelled out, right? So our motive of multiplying the first equation by T2 and second equation by T1 is resolving over here. So we get U times T1 T2 into the RHS plus half G T2 square into T1, right? So add the LHS and add the RHS. Into the LHS you can see H can be taken common and we are left with H times T1 plus T2 into the bracket we will write over here, right, is equal to, you can cancel out this term U times T1 T2. Yeah, it will just cancel the red and black. Yeah. Now we are left with half G T1 square T2, half G T2 square T1. So half G T1 T2 can be taken common and into the bracket we are left with T1 plus T2. You can also see T1 plus T2 is coming into the LHS, T1 plus T2 is coming into the RHS. So just cancel it out, right? So we are left with H equal to half G T1 T2, right? Half G T1 T2. As given into the question, you can see the last line, if the body is falling freely from A, right? So during the free fall, I am writing over here, during the, for the body, for the ball, when it's falling freely, that is it's simply dropped. That means its initial velocity will be 0. So s equal to ut plus half t square will give s equal to 0 into t plus half gt square, right? This is the time which we need to calculate, that this t is equal to root over t1 t2. So here it will be t, no t1 or t2, right? So from here putting up the value s equal to h, and the ut will be cancelled out because u initial velocity for dropping case is always 0. So we are left with h equal to half gt square. And in the above with black color we have already derived that h equal to half g t1 t2. So just equate these both the equations, right? H equal to half gt square will be coming as equal to half g t1 t2, right? Half g t1 t2. You can see very clearly that 1 by 2 z is common into the LHS and even into the RHS. So cancel it out. 1 by 2 z will be cancelled and we are left with t square equal to t1 into t2, and taking over the root into the LHS and RHS we are left with t equal to root over of t1 and t2. This is the derivation which we were requiring, and we are just solving this above equations to derive on this So this is the time taken by the ball when it's dropped freely, when T1 and T2 are the respective time for ball thrown upward and dropped and thrown downward with velocity u, right?